So in this video, we'll be learning about alternating series and the test. So what is alternating series? As the name suggests, alternating means that the sign is alternating each number. And what I mean by that is just let's look at a simple example. We have the following series 1, negative 1 over 2, comma 1 over 3, comma negative 1 over 4, and so on. So the main thing that you see here is that the sign is changing each number, right? First one is positive, negative, and so on. And it doesn't matter if you start with a positive or negative number. We can also have negative 1 as the first term, and then 1 over 2, negative 1 over 3, 1 over 4, and so on. So the main thing is the sign changes each number. And what we want to do is we want to find the sum of all these numbers. So 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 and so on until we have like 1 over n, and n here is approaching infinity. So we can denote this by the following formula, which is sigma of negative 1 to the power of n plus 1 multiplied by 1 over n, and n here is equal to 1 and n is approaching infinity. So if you substitute 1 as the first term, you will get negative 1 to the power of 2 multiplied by 1 over 1, which is also 1. So you get the first term, which is 1. And if you put n as 2, you will get negative 1 over 2. If you put n as 3, you will get 1 over 3. So this is the general format or formula for generating this series, right? And there are two main components in this part. So the negative 1 to the power of n plus 1 here is just to generate the sign and alternate each time. If you put 1, you will get a positive sign, positive 1, which we just want to focus on the sign here. And if you put n as 2, you will get negative 1 to the power of 3, which will be negative 1. So this part here is just to alternate the sign. Now this part, which is 1 over n, if you notice, this is to generate the value. So each time it's generating 1, 1 over 2, 1 over 3, 1 over 4, and so on until 1 over infinity. So these are the two components, and the 1 over n, the part where you generate the value, is called use of n. So un. And for any general alternating series that you will see, they are denoted by this. So it's going to be negative 1 to the power of n, and sometimes it could be starting with a positive number, negative number. So that's why it depends if you want to do the power of n or to the power of n plus 1, and n is going to be equal to 1 over here and infinity, and you are multiplying it by use of n, where we just discussed about this. And we have a test for alternating series to check if it converges or diverges. It's called the alternating series test, denoted by AST. So we have three conditions that we need to check in AST. I'm going to write them in white or red. So the first condition is that u of n is always positive. So we can also compare it to the example that we just did and check these conditions. So here we have u of n to be equal to 1 over n, which is a positive number, right? Because n is going to be 1 to infinity, it's always positive, and we have a 1 over here, which is also positive. So it checks the first condition. Now the second condition is u of n is decreasing. So what I mean by this is, as n is approaching infinity, we want u of n to be decreasing. And if we check that for our example over here, as n increases over here, we will have 1 over 1, 1 over 2, 1 over 3, 1 over 4, and so on. So it also satisfies the second condition, right? Now the third condition is we check for the limit of u of n from n is approaching infinity and check if it is equal to 0. If it is equal to 0, then this condition is also satisfied. And here we can try that. We have 1 over n, which is n is approaching infinity. So we have 1 over infinity, which is equal to 0. So it checks for all these three conditions. And if all these three conditions are satisfied, this means that the series is converging. And if any one of these conditions are not satisfied, you can directly say that the series diverges. So you don't need to check all three of them. If one of them is not satisfied, this means that the series is diverging. If all three of them are satisfied, this means that it's converging. And another thing is you can jumble up the order. It doesn't matter if you start with this condition first or this condition first. Whatever is more easier for you to check first, doesn't matter. And you can also try this one first, and there is no order, I mean to say, to how you start the conditions. And here this series is called alternating harmonic series. Okay, my bad. Harmonic series. So as we know, this part over here is called the p series because we have 1 over n, and n here is just p, right? And if we had this separately without this part, the alternating part, this would be diverging, right? So this alternating makes a huge difference, by the way. We have an alternating harmonic series which converges. So now let's start with some examples and questions so that this is more clear. So in our first example, we have the series of negative 1 to the power of n multiplied by n over n plus 1, and n here is equal to 1 all the way to infinity. So first of all, identify what is your u of n, which is going to be this part. So let's write u of n here, and let's check the three conditions. The first condition is that, okay, actually let me paste that condition, three conditions next to the question, so that's more easier to look at it. So these are the three conditions. The first condition is that u of n is always positive from n is equal to 1 all the way to infinity. And if you look over here, it is always going to be infinity or always going to be positive since there is no negative sign. So the condition first one is a tick. Now the second condition, u of n is decreasing. So as we approach n is equal to 1 all the way to infinity, u of n has to decrease. So let's try some numbers. We're going to try 1 over 1 plus 1, which is 2, and then we have 2 over 2 plus 1, which is 3, and then 3 over 4, and so on. And if we check this is going to be 0.5, this is going to be 0.6, and so on, 666, and then this is going to be 0.75. So here we can see that the numbers are increasing instead of decreasing. So here the second condition is not satisfied. Now the third condition is you take the limit. So actually here in the second condition you can just stop and say that the series diverges, but just to sake of it, I'm gonna do the third condition also. U of n, which is n over n plus 1, n is approaching infinity, and this is actually equal to, is gonna be I'm gonna use the L'Hopital rule here, which is take the highest degree coefficient is going to be 1 over 1, which is 1, which is not equal to 0. This means that even the third condition is not satisfied. Now one very important thing for the second condition is that you cannot take numbers like 1, 2, 3 and such like small numbers. You need to take huge numbers like 1000 and compared it to 2000 or compared to 10,000 and see the difference over there. So that's a very important thing also. So sometimes, just like if you substitute small numbers, just put a question mark and then test the third condition. And if you want to do the second conditions, try with very large numbers. And here, if you substitute 1000 and 2000, you will get that the series is increasing also. So here the series has to diverge since it's not satisfying the condition. So here you could have just started with the third condition and just test it out instead of doing the first two, because you can see here is n over n plus 1, and you know that using the L'Hopital rule is going to be equal to 1, which is not equal to 0, and you can directly say that the series is diverging. So let's do our second example now. We have the series of -1 to the power of n and 2 to the power of n over n squared, and we have n is equal to 1 all the way to infinity. So the first step here is to identify your u of n. So our u of n here is actually 2 to the power of n over n squared. And now let's do our three tests. AST, the first condition. U of n is always positive from n is equal to 1 all the way to infinity. We have 2 to the power of n, which is always going to be positive if you put any n over here, and we have n squared, which is also always going to be positive. So the first is a tick. Now the second condition is u of n is decreasing when we are going from n is equal to 1 all the way to infinity. We have actually 2 to the power of n over n squared, right? And we know that this is an exponential function. An exponential function is increases at a faster rate than this function, right? Because the power here is n, and here we have the base as n, and it's to the power of 2. So if you just try some numbers, let's say not small numbers actually, so like huge numbers like 10, and then try 20, 30, and you will see that it is definitely increasing. So here the test fails at the second condition. Now if you want to just do the third condition just for practice, let's do that. Let's take the limit of n is approaching infinity of 2 to the power of n over n squared. You will again get that this is infinity since you have an exponential function, and you can use a L'Hopital rule. So you'll get something like, because this is the same, it's going to be 2n, 2 to the power of n over 2n, and then you do it one more time, so you'll get 2n over 2, and this is definitely infinity, right? So here third condition also fails, so this series diverges. Again, once again I'm mentioning this, you can just stop at the second condition, that if it fails then this series diverges. So now let's move on to our third example, and this is a more complex one. So we have -1 to the power of n, 10 to the power of n over brackets n plus 1 factorial, and we have n is equal to 1 all the way to infinity. So now let's start with our AST. First condition is u of n always positive? And sorry about that, I skipped identifying the u of n. Here the u of n is going to be 10 over n over n plus 1 factorial, and you can see that this is of course the sign generator, and everything else is u of n. So here if you try any number from 1 to infinity in n, is this ever going to give you negative answer? No, right? Because this is, the numerator is always positive, the denominator is also always positive. So the first condition is a tick. Now the second condition is u of n decreasing. For that we can try like huge numbers, like substituting 100 and then 1000 and compare it. but I'm just going to skip it for now and move on to the third condition, which is the limit. So if we take the limit of n is approaching infinity, what will we get? Will it be 0? So uh, I have mentioned this before. One general rule that you need to remember is that factorials are increasing at a faster rate than exponentials, or increasing at faster rate than base exponential. And what I mean by base exponential is, here we have 10 to the power of n. Now if we had n to the power of n, which is like the base is also increasing, then this is increasing faster than the factorial. But here we have 10 to the power of n, so here the denominator is actually increasing faster than the numerator, so here it is actually equal to 0, which also takes our third condition. Now if we go back to the second condition and substitute, let's say, let me try actually 10 and I'll check the answer. So I substituted n as 10 and we got the answer of 250. Now let's try n to be, let's say, 20 and see what the answer is. So we are gonna get, oh, it's gonna be 1.9. So you can see the immediate effect of the factorial taking over after n is increasing. So here we can conclude that the u of n is always decreasing, and the second condition is also fulfilled, and here we can conclude that it is a converging series. So once again, the most important thing here to remember is, when we have a base, let's call it any integer, let's call it a to the power of n over n factorial. In this case, the factorial is increasing at a faster rate than the numerator. Now if we had, instead of a, n to the power of n, and here n is also increasing, right, because it's equal to 1 and goes all the way to infinity, then if you have this case, then the numerator is increasing at a faster rate than the factorial. So here are like some quick tips that you need to remember, and this is one of them. And here we have the case of a, actually, where a is equal to 10, and this means that this is the denominator is increasing faster than the numerator. So that's all for this video. I hope that you understood this topic, and if you have any doubts or any questions about any of these questions, you can feel free to ask them in the comment section. I'll be more than happy to answer. And thanks for watching. I'll see you next time.